And to speak on this, we have Dr. Deepak Verma, who is a medical officer in the Central Health Services here in Delhi. And he is also working at the Department of Anesthesia, Atal Bihari Vajpayee Institute of Medical Sciences and Dr. RML Hospital. And his special interest is in pediatric anesthesia. Over to you, Dr. Deepak Verma. Please go ahead.
Thank you, sir.
Good afternoon. So today during this
I think there is some issue.
Good afternoon, respected chairperson sir, respected HOD madam, esteemed faculties of RML and my dear students. So today during this short lecture, I'll be giving you an overview on soda lime, which is commonly employed in closed and semi-closed system. What is a circle observer system? It is a system which involves a means of CO2 removal from exhaled gases to avoid rebreathing and hypercapnia. This is a diagram of classical circle system in which gas flows in a circular pathway through two separate channels, that is the inspiratory limb and the expiratory limb. Gas exhaled by the patient is removed by the CO2 absorbent system, which is present over the downstream in the expiratory limb. Observer was needed to overcome disadvantages of Mapleson circuit, which includes requirement of high fresh gas flow to prevent rebreathing, wastage of anesthetic gases, OT pollution, loss of patient heat and humidity. Ideal CO2 observer should be cheap, easy to handle and highly efficient in CO2 absorption. It should also possess feature of lack of reactivity with common anesthetics and absence of toxicity and low resistance to air. There are 5 basic components of classical CO2 observer system, namely canister, housing, baffles, side tubes and bypass. Coming to the canister, it holds absorbent, side walls are transparent, heads and base are made up of metal and plastic. Perforated screen at bottom holds absorbent in place. Space in base allows dust and moisture to accumulate and thus it prevents caking at the bottom. Sizes may be large and small and are available in form of single or double canister in series and are available in disposable or pre-packed canister form. Housing is basically the spaces at the top and bottom of the absorber for incoming gases to disperse before passing through soda lime or for outgoing gases to collect before passing through the circle system. Thus, it promotes even distribution of flow of gases through the CO2 absorber. Baffles are annular ring placed at the bottom of the canister to direct gas flow towards the central part of the canister. Coming to the side or the central tube system, it conducts gases from the bottom of the canister into the breathing circuit. Coming to the bypass valve, it is a manually operated valve which allows complete bypass of exhaled gases from the absorber and thus allow operator to change canisters during ongoing cases. Coming to the pattern of flow in canister. Exhaled gases flowing through soda lime have tendency to travel along periphery of canister. Hence, initial absorption occurs at the inlet followed by side walls of the canister. When terminal exhaustion occurs, there is a blind spot which remains in the distal canister as shown in figure C. Basic principle behind process of carbon dioxide absorption through soda lime is that acid neutralizes base. Here acid is carbonic acid which is formed when carbon dioxide present in exhaled gas reacts with water present as a thin film on the surface of soda lime granules. Bases commonly used in soda lime are sodium hydroxide or potassium hydroxide, which neutralizes carbonic acid leading to formation of sodium carbonate. This sodium carbonate further reacts with slaked lime, that is calcium hydroxide, to form calcium carbonate, and thus ultimately soda lime removes carbon dioxide from expired gas. Roughly 100 gram of soda lime absorbs 23 liter of CO2 and liberates 13.7 kilocalorie heat for every 1 mole of CO2 absorption by soda lime. This step is rate limiting step for whole process. Now the question arises, why not calcium hydroxide being base directly reacts with carbonic acid? Answer is, reaction between calcium hydroxide with carbonic acid is a very slow reaction. While sodium and potassium being placed higher in the periodic table reacts readily with carbonic acid in comparison to calcium hydroxide. You must also notice that sodium hydroxide, which was converted to sodium carbonate, is again regenerated back to sodium hydroxide in final reactions. Hence, sodium hydroxide is considered as a catalyst. There are four types of carbon dioxide absorption. Some formulations of soda lime are high alkali absorbent containing high content of sodium hydroxide or potassium hydroxide. Desiccated absorber has reduced efficiency, increased risk of carbon monoxide and compound A formation, and also it does not change color on exhaustion. Low alkali absorbents contain reduced amount of sodium hydroxide and potassium hydroxide. While alkali-free CO2 absorbent mainly contains calcium hydroxide with significantly less carbon dioxide absorption capacity, there is no risk of compound A and carbon monoxide formation even after desiccation. Color indicators works very well even when dry. This property has been used to indicate dehydration in high alkali absorbent canister by placing alkali free absorbent at the side where fresh gas enters the canister. Lithium hydroxide absorbent are expensive and does not require catalyst. Coming to the composition of soda lime, classic soda lime contains 80% of calcium hydroxide, 3% of sodium hydroxide, 2% of potassium hydroxide, and water content being 16%, while new soda lime does not contain potassium hydroxide. Trace of silica and kieselguhr is used as a hardening agent. Optimum size is 4 to 8 mesh size. Indicators are used in both classic soda lime and new soda lime. This table depicts various other forms of soda lime. CO2 absorption by soda lime generate heats, hence failure of canister to become warm may be used as a sign of exhaustion. Remember, granule size is measured always in mesh number. Mesh number is basically number of openings per square inch of mesh. Optimum size is 4 to 8 mesh size. Coming to the another concept, hardness number. It is measured as a percentage of soda lime that remains on 8 mesh size screen after agitating it with steel balls. It should be more than 75. Coming to the indicators, it is an acid or base whose color depends on pH and signifies exhaustion of soda lime without affecting CO2 absorption. Ethyl violet is most commonly used indicator as its color change is vivid and of high contrast. Coming to the another concept, peaking or regeneration of indicators. It is seen with soda lime that contains strong bases which appears to get reactivated with rest. Hence, rested canister gives false impression of its usefulness. Other indicators include phenolphthalein, Clayton yellow, ethyl orange, and mimosa Z. Coming to the adverse reactions which has been noted during interactions of volatile anesthetic agents with soda lime. Desiccated soda lime and high alkali absorbers lead to formation of carbon monoxide and compound A, while degradation of halothane leads to formation of haloalkenes. Incidence of carbon monoxide formation is reported more during first GA case of a day or Monday morning because of fresh dry gas flowing into the circle system causing absorbent to become dehydrated. It is more commonly seen with desflurane followed by influrane, isoflurane and halothane along with sevoflurane. High alkali desiccated soda lime are at greater risk for CO formation and compound A formation. Choice of anesthesia agents, temperature inside absorbers, and rate of fresh gas flow are other determinants of carbon monoxide formation. With desiccated soda lime, sevoflurane can undergo base catalyzed degradation into fluoromethyl 2,2-difluoro-1 trifluoromethyl vinyl ether, which is also known as compound A, which are known to be nephrotoxic to rats but not to humans till date. Halothane may degrade into 2-bromo-2-chloro-1,1-difluoroethane. Excess heats and fire may be noted with desiccated absorbers. Anesthesia Patient Safety Foundation provides recommendation to reduce risk of volatile anesthesia degradation, which includes turning off gases when not in use, changing absorbers regularly at least once a week or when indicator changes color, or at least when there is uncertainty lies about hydration of soda lime. Soda lime containers should be closely tied. When to change the absorbent? Inspired CO2 level is the most reliable indicator for change of canister. Other determinants include color change of indicator, canister temperature, and excessive dust present in the canister. Take home message from this lecture will be: circle breathing system requires a means of CO2 removal from the exhaled gases to avoid CO2 rebreathing and hypercapnia. Soda lime is most commonly used CO2 absorbent. Optimum size is 4 to 8 mesh size. Advantages being recycling of anesthetic gases reduces economic burden to institutes, patient heat and moisture are retained, less OT pollution, flammable gases are enclosed in circle system, roughly constant composition of gases are delivered to the patient. Disadvantages being soda lime canister is heavy and cumbersome instrument, breathing resistance and dead space is higher, exothermic reaction leads to rise in patient body temperature, alkaline dust is harmful to patient's respiratory mucosa, cross infection from apparatus has been reported, there is chance of circle leak and accidental hypercapnia.
Thank you so much. Thank you so much, Dr. Deepak Verma, for a comprehensive coverage of the topic that was given to you. That's soda lime, very important topic again. It has a lot of significance because these days there's a lot of stress on prevention of pollution, environmental pollution. These inhalation agents that we use, you're all familiar that they do cause some sort of environmental pollution, and there is a greenhouse effect, which there's a lot of, I would say, significance in today's world because of the pollution that is there. And there is, because of this, there is more stress on low flow anesthesia. This only is to ensure that the leakage of the inhalation agents to the environment is as less as possible, so that not only the people who are delivering or giving anesthesia to the patient, other persons also who are present in the OT at that point of time are safe. Some of the common questions which are asked with regard to the soda lime in the examination is what are the indicators that are commonly used, and what sort of color change that occurs with the use of these indicators in the soda lime. When we come back to the previous presentation, if I can see in the chat box, there is one question which is on Smith's test that I can see. Then why should we use auxiliary outlet in case of high frequency ventilation? I will pass on these questions to Dr. Akhilesh, who has covered the topic so very nicely, starting right from the history. So just to go back a bit on this, he started with the slide that it was a modification of the Guatemala machine, which Henry Edmund Gaskin Boyle ultimately gave his name to. Yes, it is. The history says that there was some sort of exhibition where this gentleman James Taylor Guatemala, that was his full name. He had exhibited his machine in one of the stalls at that point of time. And this Henry Edmund Gaskin Boyle also happened to attend that exhibition, and he was very impressed with the machine. So he took one machine from there and brought it to the UK where he was working, and he changed the calibrations of the pipeline connection and all that. And after doing that, he gave this machine, which was actually the same concept of James Taylor Watchme's machine, but just with the change of the pipe size connections, which could fit into the British system rather than the American system. He gave it his name, James, the Boyle's machine. He was quite a flamboyant and very active, proactive, I would say, kind of person. So, and from there on, the name Boyle's machine was everywhere. So James Taylor Guatemala was somewhat sort of a low bat, a laid back kind of perhaps approach, and that's why his name doesn't come anywhere near. So when the first machine was described by Boyles, it had 4 nitrous oxide cylinders and it had 1 large oxygen cylinder. And at that time, the pressure regulators, they had a spirit lamp. I mean, it's so dangerous. I don't know how they escaped major sort of disasters in the OT. So these pressure regulators, because they would cool down, and once they cool down, they would quite often obstruct. So to keep them warm, they even had sort of spirit lamps under them so that they remain warm and they don't get occluded. So after the initial machine, which was described in November 1917 by Boyles, subsequently another change that occurred was in 1920, ether bottle was added to it. And in 1926, chloroform was added to it. And in 27, there was addition of the back bar and carbon dioxide side feed tube was added to the whole apparatus. Plungers and cowls came in 1930, plungers and cowls, and dry bobbins replaced the water side feed mechanisms of determining the flow of gases in 1933. And rotameter came in 1937. So that's how the various changes occurred. And these days, apart from the mechanical components, as Dr. Akhilesh also said, there's a lot of stress on the computerized system, chips and all that, which do all that system. With regard to pen index system, a very important question, again, not only the examination for the practical examination, from theory point of view, there may be some small notes sometimes on this. The 3 main things that you must remember with regard to the combination of the gases is 1,5 for air, 2,5 for oxygen, and 3,5 for nitric oxide. So it's easy to remember, so you won't forget it. If you know these 3, no examiner is going to fail you on that. Cylinder testing, again, Dr. Akhilesh has touched upon, is normally done every 5 years. And, and sometimes with extended testing, it may be after 10 years. Also, there are various tests. One of the most commonly performed tests is the hydraulic test, where they put in, water and they pressurize it to nearly 2 times its service pressure, and so that is the hydraulic test, which determines the safety of the cylinder. Every 5 years this is done. Oxygen failure safety device, yes, this also has been mentioned very, very clearly. When you are checking the machine, this again has been highlighted that after you check the machine, one of the things which are often overlooked is the presence of the spanner. So you think that cylinder is there, so it's there. I mean, even if you have 10 cylinders with you, but in case you do not have the spanner or what we normally call as the key, if you don't have that, you can't open the cylinder. So all those 10 cylinders are useless in case you don't have the mechanism to open that. Oxygen is downstream, again, very well highlighted by Dr. Akhilesh. But sometimes in some of the machines, you would see that the oxygen seems to be on the left-hand side rather than the right-hand side, which should be the downstream, as it is said. It must be, I would like to add that there is a mechanism, a shelf life mechanism. So even if it appears to be on the left-hand side of the flow meter, but eventually the delivery of the gas is downstream because there is kind of a shelf mechanism. The nitrous oxide meets the oxygen gas, and oxygen is the last gas that is to be added to the mixture before it goes to the patient. So these are some of the few inputs. And I would now pass it on to Dr. Akhilesh to mention about that Smith test, which one of the members who is attending this PG assembly has asked for. Dr. Akhilesh, please.
Thank you, sir, for the input, and what you talks about the experience, sir.
Thank you.
And as far as our Smith test, when we talk about the Bain circuit, I had not covered it because I thought it would be covered in we have a further class on the breathing circuits. So when we talk about the Bain circuit, there are two tests. One is APPEC test and other is a Smith test. Smith test, you find something new, but it is just another name of an ampule test. When we talk about the Bain circuit, we are more worried about the inner tubing, whether there is no leak in the inner tubing. Why so? If there is any leak in the inner tubing, the whole circuit becomes the dead space. So you are very much worried about the leak in the inner tubing. So to test that, one is that you keep the flows at 5 liter or 6 liter per minute and then put a small ampule. There is a specific thing made by Intrasurgical also. They have a company made blocker, or you can put in a small ampule or put in your finger also on the inner tubing, and you will find that if it is patent, they will be going down of bellows. So that's, you can see. And another is a APPEC test, which again, something which you should all know, that is based on the Venturi principle, that whenever you put the oxygen flush on, the bag collapses. So because of the Venturi principle, when you push the flush on, the gas goes at a high rate, and then there's a vacuum created, and then the bag collapses. There are two more questions. What to expect in a universal leak test if one vaporizer is open and another closed? You have to open a vaporizer and then do the leak test. And leak test should not be there. And then close that and then open the another vaporizer and then close it. Right? Why should we use auxiliary outlet in case of a high frequency ventilation? Yes, you should use auxiliary outlet because you want to preserve the common gas outlet in case of a necessity. Suppose you want to supplement it with the oxygen. You have attached one outlet to the common gas outlet for a high frequency, and your jet is not working. You need another source. So for that, you always use the auxiliary outlet for doing the supplement thing, keeping the main common gas outlet as a reserve in case of a need.
So, thank you so much. Thank you so much, Dr. Akhilesh. I think we are nearing the end of our time. There is no more query that I can see in the chat box. So before we close this session, I would like to thank once again the team RML Hospital, very ably led by a very dear colleague of mine, Dr. Mondeep Kaur, and of course, dedicated workers that she has with her in the department. So thank you so much, team Dr. RML Hospital, for giving me the opportunity to be here with you. And of course, I would like to congratulate once again both the speakers, Dr. Akhilesh as well as Dr. Deepak Verma, for a very comprehensive coverage and living up to the requirement of the topic that they have been assigned. Thank you so much, and over to you, team RML. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, Baljit, sir. Thank you, Akhilesh, sir. Thank you, Dr. Deepak. It was a nice presentation. Now, We will take a short lunch break and we will come again and start our session at 2:45. Thank you. Welcome back, everyone. Now we have a very eminent faculty among anesthetists for this session. We have a long case presentation, a 60-year-old male posted for right pneumonectomy. The external examiner for this session is Dr. Rakesh Sharma, sir. Gurmeet, slide, please. Sir is a professor emeritus, and sir is affiliated to Dr. Baba Saheb Ambedkar Medical College, and interest of area is airway management and resuscitation. And the moderator for this session is Dr. Devang Bharti. He is assistant professor at Dr. RML Hospital, and area of interest are difficult airway, obstetric anesthesia, and palliative care. Welcome,